Alright, so, I'll review, like I said, some stuff you've done in geometry, some you did in Algebra 1, all exponent stuff, that is our next unit, exponents. Did you grab my answer key?
It's on the top.
Thank you.
No.
And did a name on it for me. Thank you. Were you wondering why it was all filled in?
A little bit, yeah.
Wait, here, let's swap. I'm gonna do a hair deal.
Alright, so, hey, fellas, we're started. Let's go. So, I can statements. Simplify using negative exponents, multiple variables. We're talking about adding, subtracting, multiplying, dividing, exponents, evaluating functions, solve multi-step radical equations, evaluate interest. We're going to talk about exponential growth. We're going to talk about a growth rate, things like that. All stuff we're going to cover in this unit. I think it actually says it's 11 days. Right? I think if you look at the end of the unit, I think it says like group work and then day 1 review and day 2 review. So we throw a lot of review in there at the end of the unit.
That's too much.
It is a lot, isn't it? So, hey, relax. So it is kind of a long unit. I apologize for that, but it is what it is. So, exponents. First things first, we should all know what an exponent is. If you don't know what an exponent is, you are in the wrong class. Exponents tell us how many times a number, which is called the base, is used as a factor. So a power has 2 parts, a base and exponent. The power is the whole thing. So the power is x cubed. The power is 5 cubed. Right? The base is x or 5, and then the exponent is 3, obviously. X cubed means x times x times x. 5 cubed is 5 times 5 times 5. We should all know that already. Anything with a 0 exponent. So anything raised to the power of 0 is equal to 1. 3 to the 0 power is 1. X to the 0 power is 1. Fire truck to the 0 power is 1. Literally anything. Anything at all to the 0 power is equal to 1. Alright? Doesn't matter what it is. Anything to the 0 power is 1. So
like Jared to the 0 power is 1?
Jared to the 0 power is 1. Cole to the 0 power is 1.
What about Hayden? Yeah, what about me?
Hayden to the 0 power is still 1. Everything to the 0 power is 1.
I thought mine was negative.
So, negative exponents. X to the negative 2 is an unsimplified power. We call it an unsimplified power. What that means is if you write it as an answer, it will be marked wrong. Right? We want our powers all simplified, which means any negative exponent needs to be simplified into a positive exponent. Alright, like I said, if you write any final answer with a negative exponent in it, it will be marked wrong. What we do is we take, if we have x to the negative m power, to make it a positive exponent. Technically, it is in a numerator right now. X to the negative m is the same as x to the negative m over 1, right? Anything with a negative exponent, to make it positive, if it is in the numerator, it will go to the denominator and become positive. If it was in the denominator and it was a negative, we would move it to the numerator and it would become positive. Alright, so any negative exponent we're going to move to make positive. If a whole fraction is raised to a negative exponent, we're going to flip the whole thing and it becomes a positive exponent. Alright? Yep. Just kind of remember this from geometry last year?
I wiped that clean.
Alright, so let's simplify the expressions. All negative exponents must be positive. First one, z to the negative 4th. We just said, if I want to make this a positive exponent so I can write an answer, right now it's technically in a numerator because it's technically over 1. I'm moving it to the denominator. It's become 1 over z to the positive 4th. That's my answer. Right? Do not leave it as a negative exponent.
Okay.
Number 2. Number 2.
1.
1. Right? 27 to the 0 power is 1. Anything to the 0 power is 1. Number 3.
Ooh, I got this.
First of all, hey, there's multiple things wrong with this. But what's one thing wrong with it?
Negative exponent.
It has a negative exponent, so let's fix that right away.
Yeah, put it on top.
Shh, relax. So, only things with a negative exponent are getting moved. M is to the negative 4th power, so it's the only thing we're moving here. Alright? It is being moved to the numerator to become positive exponent. So I get 2m to the 4th x squared over 4n squared. Now, do you think it matters if I write m to the 4th x squared or x squared m to the 4th?
No.
No, I really don't care what you order. Now, me, being OCD with my brain, I have to write it in alphabetical order. 99.9% of the time, I will write them in alphabetical order, left to right. You do not have to. If you want to put x squared before m to the fourth, I'm perfectly okay with that. Okay? Now, is that a good answer?
No.
Why not?
Two can be
Can
simplified to 1/2.
Can be simplified. 2 over 4 can simplify to 1 over 2. So my final answer, m to the fourth x squared over 2n squared. Now, if you put a 1 on top, are you getting it marked wrong? No. That's perfectly fine. If you want to leave the 1 in there, that's perfectly fine with me. Helps you remember that, that's fine. Alright, number 4, 5x to the 0 power. 1, right? Everything to the 0 power is 1.
1.
Number 5, a to the negative fourth, b squared c.
Negative exponent.
Negative exponent, right? So let's move it.
Good job.
A to the negative fourth goes into the denominator, so it becomes b squared c over a to the positive fourth.
Good one.
And I can't simplify anything, so I'm done. And lastly, 6. 2 to the negative 1, x squared over m to the negative fourth, n squared. Well, I have negative exponents again. So I have 2 to the negative 1. Move that to the denominator to make it positive. M to the negative fourth to the numerator to make it positive. So I get m to the fourth x squared over 2n squared. Now, if you want to leave it as 2 to the first power, fine with me. Right? Any questions? We're good so far? Sweet. Multiplying exponents. So first and foremost, you need to have the same bases. So bases must be equal. I cannot do x squared times y cubed. Doesn't work. I don't have the same base. Right? I need to have the same bases, and what's going to happen is I'm adding my exponents. So if I take x squared times x cubed, I'm going to add 2 and 3. It becomes x to the fifth. Alright? Now vice versa for dividing exponents. Right? Multiplying, we're adding exponents. Dividing exponents, we are subtracting them. Alright, so x to the a over x to b equals x to the a minus b. If b is greater than a, we're going to do it on the bottom. You don't need to listen to this. That's just keeping you from getting a negative exponent. You can, if you'd rather do it this way, go ahead and do it. I shouldn't cross it out then. But I'm going to do it this way every single time. And what's just going to happen is I'm going to get a negative exponent. And I'm going to flip it to the denominator then.
Okay.
Alright, so I like to stick with 1, so you just have to remember one of them. But if you want to try and remember that one as well, you can. So let's try some. First and foremost, let's do our multiplication. Right? 5m to the negative fifth n cubed p to the negative first times 2m to the fourth p squared. Well, let's multiply our like terms. First of all, our whole numbers. 5 times 2 will give me 10. Right? Then I'm going to do my bases of m. m to the negative fifth times m to the fourth. Be m to the negative 1, right? We're adding exponents. Negative 5 plus 4. Then I'm going to do my base of n cubed times, there's nothing over here, just stays n cubed. Then p to the negative 1 times p squared. Negative 1 plus 2 gives me p to the first. Circle it, call it a day?
No. Negative exponent.
No, we have a negative exponent. So 10 n cubed p to the first over m. And if you want to put to the first, you can. If you don't want, you don't have to. But that should be our answer. Okay? Does that make sense? Let's start to come back a little bit. Sweet. So second one, same thing. Whole numbers first. 2 times 3 will give me 6. Bases of x. X squared times x to the fourth. 2 plus 4 is x to the sixth. Y cubed times y to the fifth. 3 plus 5 gives me y to the eighth. Z times z squared. Hey, what is that going to equal? Z to the third. Why is it the third? It's a 1, right? If there's an exponent that's not there, right? Just z or just x or just y, that means to the first power. So when I add my exponents then, 1 plus 2 will give me 3. Okay. Let's try some other ones. Division. 2x squared over 4, x to the negative fourth, y squared. Well, first of all, 2 over 4 becomes 1 over 2. Right? X squared divided by x to the negative fourth. Well, I'm subtracting my exponents when I divide. 2 minus negative 4 will be positive 6. Right? And then am I dividing anything with y squared? No, so it's just going to stay the same. It stays on the bottom there. If you want to just have x squared over 2y squared, that's fine as well. Does that make sense so far? Okay. 4. G squared h cubed over g to the fifth h to the fifth k to the negative 2. Same thing. Go piece by piece. Use your common bases. G squared over g to the fifth. That leaves me with g to the negative third, right? 2 minus 5 will be negative 3. And I'm going to always do that first so where I end up on top. H cubed over h to the fifth. 3 minus 5 gives me h to the negative 2. And then k to the negative 2 is on the bottom. So I have negative exponents, so I'm going to flip everything. Everything in the top with a negative exponent comes to the bottom. Everything in the bottom with a negative exponent goes to the top. So I get k squared over g cubed times h squared. Right? Does that make sense? Do you have any questions on that so far? I think we're over halfway done already.
Woohoo!
Alright? Okay, last few rules we're going to talk about power to a power with exponents. So, power to a power, we're going to multiply our exponent. So if it's like a to the m power and then you raise it to the n again, we're multiplying your two exponents, m times n. Alright? Same thing if we have a power to a product of a power. What's going to happen is we're going to multiply our exponents, but we're distributing it to both of those pieces. So a to the x to the m becomes a to the x times m. B to the y becomes b to the y times m. Right? And then quotient, same thing. It goes to both of our pieces here. We're distributing it and we're multiplying our exponents. Alright? Does that make sense? Should we try some examples? Alright, let's do them.
Alright.
First one, ab to the negative fourth, all of that squared. So remember, if a doesn't have an exponent, it's a 1. So if I bring this 2 to both these pieces, I'm multiplying the exponents. I should get a squared b to the negative eighth. And I got to change that negative exponent to positive. Put it to the bottom. So a squared over b to the eighth. Okay, does that make sense? Alright. Same thing here. This 3 is going to all of these pieces here. We're multiplying. Well, it becomes 2 cubed. C to the 9th. 3 times 3 is 3. D has an exponent of 1, so it becomes d cubed. F to the third. Raise the third. 3 times 3 is f to the 9th. Do you think that's a good way to leave your answer?
No.
Why not?
A 2.
What about the 2?
It should be cubed.
Cube it. We know how to cube it, right? With variables, we can leave those exponents. With whole numbers, guys, do that operation. If you leave 2 cubed, I'm going to mark it wrong. Right? You should know what 2 cubed is. You can put it in your calculator, right? Use the caret key. Or think 2 times 2 times 2. Right? It should be 8. So it should be 8 c to the 9th d cubed f to the 9th. And that should be your final answer. Simplify it as much as possible. Alright, number 3. This 2 is being distributed to all of my pieces on top and on bottom, and I'm multiplying the exponents. 2 squared x to the 4th over m to the negative 8th n to the 4th. Right? 2 times 2 is 4. Negative 4 times 2 is negative 8. 2 times 2 is 4. Alright, then simplify it, right, with your 2 and change your negative exponent, bring it to the top. 4 m to the 8th x to the 4th over n to the 4th. And that should be your final answer. Okay? Number 4, there's 2 different ways to do number 4. 2 different ways. The first way is the way I would suggest doing it and the way that I will do it most often. But I will also show you the other way. So the first way you can do it, take the whole expression that's raised to the negative 2 power and bring it into the denominator. Make it 1 over 5x to the positive 2. Right? Take the whole expression and make it a positive exponent. So then it becomes 1 over, that 2 goes to both of these, so 5 squared x squared, or 1 over 25x squared. And that's your answer. Or, you can distribute the negative 2 first, becomes 5 to the negative 2, x to the negative 2, and then we know we got to flip that, make them positive. So it becomes 1 over 5 squared x squared, which becomes 1 over 25x squared. So you get the same answer, you get to the same result. I would, if I was you though, just do it the first way, where we make the whole expression positive, then distribute it out, multiply our exponents. Just, that's my personal preference. I'm not saying you have to do it that way. Both ways will work. Okay? Any questions? Dos más. Dos más. 2 more.
What?
Exactly. So, number 5. A cubed b squared c, all raised to the 4th power. That 4 is distributed to all of our exponents here we're multiplying. A to the 12th, b to the 8th, c to the 4th. Done. Alright, last one. Same thing, like I said, I'm going to take the whole expression, put it in the denominator first. Make this negative 3, because it's a negative exponent, make it positive. 1 over 4, a to the negative 2, b cubed, c to the positive 3. Now, notice, guys, notice, that a still has a negative exponent. Right? The reason for that is we took and we made this negative 3 a positive 3. We took the whole expression, moved it to the denominator. Alright? So because we took the whole expression, we're worrying about this exponent right now. That a to the negative 2 doesn't change right now. Right? Later on, we're going to move it back to the numerator and make it positive. Okay? So, take your 3, bring it to all of our pieces and multiply them. 1 over 4 cubed, a to the negative 6th, b to the 9th, c cubed. Well, what's 4 cubed?
64.
Did you say 164? 64. B to the 9th, c cubed. I need to make sure I move that a to the negative 6th up to the numerator. And that should be my answer. Does that make sense?
Yep.
Do we have any questions on those rules? Nothing? Alright. Cool beans. Swipe up, subscribe.